Hello and welcome to our webinar for our new Lockup 4.5 release. So this is the second webinar for this release series. So in the meantime, we had already a different webinar on a different topic. And today the idea is that I will present you again our new developments. Yes, today our title is Smarter Forecasting with AI-Powered App. And the reason why we choose this title is regarding our new app that we developed, actually our demand forecasting app. So for everyone who used already our apps in the predictive analytics, heard this name already. So we had before already a demand forecasting app, but this is a complete rebuild of the existing one, and it's also replacing our existing forecasting AI app and the existing demand forecasting app. So don't worry, all the features that were exist in the old application are also still in the new application. Besides that, we also have a couple of other interesting topics that we want to show you today. One is the population data in the supply chain map areas and in the Isochrone apps, where we built them in. And we also enhanced our geocoding app. You can also geocode now with a search string. Then in relation to the presentation of our last webinar, in the inventory optimization, we released in the last webinar already. But now you also have the possibility to do a scenario comparison with the inventory optimization app. And we also have then the data set for the map layers. The map layers we also introduced last time, and one of the questions that came up, can we also provide the data for this one? This is actually covered in this part. So before I directly, that's already it with my slides for today, before I directly jump into the tool, there's one thing what I wanted to mention. In the webinar itself, you have the possibility also to ask questions. So last time, most of the people did this actually in the chat, but I just heard from my team, it's better that you can do this in this Q&A section. This is actually different from a regular Teams call. This feature is only available in this webinar session. So please use the Q&A session, then it's easier for us to answer your question and to refer to different other questions. Yes, so whenever you have any questions, feel free to directly write them in the Q&A session. In between, I will always jump to my colleagues who are helping me to answer them, and then we directly take them up in the call. Okay, so thank you for this one. Yes, regarding my person who never saw me before, I'm Alex. I'm the CTO of Lockup and responsible for the product development team. And every 2 months after every release, we have now this new, this webinars where we show these newest features. Okay, then let's directly get started. I will open now a blank workbook in Excel and let's go to the Lockup supply chain add-in. We go to the home, and when you most likely you don't have the app yet available. So if you don't see it, this new app, this demand forecasting, I have it already down here, the demand forecasting app. You can just click, this is always whenever we have a new app, you can click here in the app module where you can select all the apps that you want to have on your home screen. And then just make sure that you enable here this star, that you have it directly on the home screen. And then you can also access it from the home screen. So let's go back. And now the demand forecasting app is here. So let's directly start. Like with all of our apps, we also have here an input contract. To fulfill the requirements from the demand forecasting app, we have actually 3 different input tables. The interesting part here is that this time, even some of the tables the columns are not all of them are required. But I will come to this one later. So at the moment, we have 3 input tables. One is the historical demand data. Then we have future impact factors. And we also have then SKU parameters. So maybe to directly start there in the beginning, the new demand forecasting app has directly the possibility to make a forecast for multiple SKU at once. So you can work with multiple SKUs. If you just want to do a forecast independent of a SKU, then you just have to provide here in the first column an ID, and you can do it too. So you can, but you don't have to directly calculate multiple SKUs. Then let's maybe directly cover the first, and this is actually one of the most important table for the application itself. The forecast is created based on the historical demand. So here the first column, the SKU, there you provide the ID from the SKU, and then we have a date. This is the date of the demand. In our sample data, we have now here every day a demand, or nearly every day we have a demand. We can also have gaps. This is also not a problem. If you have on some days no demand, this is also fine. You can either set them to 0 or you can just leave this column out. This is the demand from this SKU then on this day. To this 3 columns, I will actually come later what we have here in addition. So we have now the possibility to influence actually our forecast by certain impact factors. So let me quickly calculate it first, and I will explain you then on the output how it will actually look like. So I will come to this future input factors later. Before I open the dashboard for you, I just want to highlight one topic. In the past, in the forecasting AI application, you had here the possibility to set the forecasting periods. But now we have the possibility to forecast multiple SKUs at once. That's why this setting is done here in this third table. Here you provide, then this is also a required field. Then we covered all the required fields. How many forecasting periods want to calculate? A period is here actually then 1 day. So if you work here on a daily basis, then you make now a forecast for 30 days. Then let's maybe take a look directly at the output. So when we run the calculation and we click on output result, then what we get here is this is first the historical data that we provided. And when we scroll further down, here we can see now actually our forecasted values. So directly from here, we see it in 30 entries that we actually then forecasted. This would be for the SKU1. Because we directly calculated 3 SKUs, then here starts actually the result of the SKU2. And besides the forecast of the demand that we forecasted, we have additionally 2 additional columns. It's actually a lower bound and then upper bound. So what does this actually mean? This is actually the lower bound and the upper bound of the confidence interval that we actually forecast. This means the result by a chance from 80%, the demand is in between these 2 boundaries. So this means you have not only a forecasting value itself, you also have actually this lower and upper bound that you can also maybe use if you want to. So, but maybe let's take a look at the dashboard itself. So in the visualization area, in this demand forecasting app, we don't have a supply chain map because a map does not really make any sense in the forecasting area because we don't work with any geocodes. Here we only provide actually in dashboard. Let's take a look at the dashboard that we get provided. So first of all, here on top, I can see actually that we work with these 3 SKUs, SKU 1, 2, and 3. And then here in the chart below, I can see actually the dots that I can see here. This was the actual demand. And then I can see here until here we had our actual demand. And from here starts actually then the forecasting itself, the forecasted demand. Then what we can also see here, we have also the possibility to do a certain cap in there that actually influences our forecasting. But I will come to this one later. Before, what is also helpful here in the dashboard, there is a detailed explanation how the forecast is actually generated. So to make it simple, in general, there are actually 3 different main components that are actually used to make the forecasting. First, the first one is the trend. So based on the existing demand, we analyze here. You can also see then a separate chart for this one. What is actually the general trend? Does the demand does it go up? Does it go down? Or is it maybe steady? This is one component. Then we have an additional component, is future impact factors. Future impact factors can be multiple topics that is not really easily predictable. For example, I will come later to one example is, for example, the Black Friday. After I showed you here the sample data result, I will show you an additional calculation where we have as an impact factor the Black Friday, because it's normally the sales or the shipments that I predict actually are going up a lot during this during 1 week, especially the week after the Black Friday or the Black Friday itself. But this has nothing to do with the whole regular year. So, and this kind of extraordinary factors you can put in with this future impact factors. So for example, one example. And then what is also coming into focus besides the trend, the future input factors, the forecasting is also directly detecting actually the seasonality. So it can detect, so here we detected now a seasonality during the week that we have, for example, a higher demand on Thursday and Friday compared to some other days. And all this analysis of the run, you can see then actually here for each SKU. When we go, for example, to SKU 2, then we also see that the trend is here. Actually, we have here a negative trend. And then we also had the different input factors here. Also, the seasonality is here actually still, it's a weekly one. But we detect here actually that the highest demand is on Thursday. And let's quickly go back to the input factors before I come to the second example with the Black Friday. What is actually new in this application? All these columns here, these 3 columns, they are actually optional. This means you can run also the same application just without these 3 columns, and then you would do a regular forecasting without these future input factors. Whenever you are using here one input factor, you don't have to use this name. I can maybe directly jump back to the next example. Give me one example. So this one here. Let's go to this example. So here I prepared an examples that we will calculate together for such an influence factor of the Black Friday. Here the same, I choose to have only one SKU, and I have here the demand also per day, but I have it an historical demand of over 1 year. So this is also especially here necessary. I choose a demand that is a bit longer than 1 year, and then I have twice the Black Friday actually in the historical demand in there. So then here I have the regular demand, and you can see on this Black Friday what was actually this day in 2023, and the week after the amount of shipments. So I made a forecast about a demo forecast of shipments of a retailer was actually increasing a lot compared to the other days. And then I added this additional column and told the system, okay, this is such an input factor, and I need to tell the system, okay, in the past, this input, so the influence of the Black Friday happened on these days. And when I go further down because we just had Black Friday, I also have the same input factor here of the Black Friday. So, and then what is required whenever you want to use this additional input factor, you need to tell the system when will be this impact, and this you only have to do for the relevant days in the future. So I told the engine here, okay, in 2025, the Black Friday is on the 28th of November. And then I assume a higher shipment data on the 29th, that is a Saturday. And then I skip the 30 because on the Sunday there are regular no shipments. And then I said the following week is also influenced by this Black Friday. Then here in the third table, I just said, okay, I want to do a forecast of 400 periods because I want to do a forecast of more than 1 year. And then I also gave him here actually a lower trend limit and an upper trend limit. This you can also influence, but here I gave him actually quite a big range available. And let's take actually a look how this input factor is actually behaving. 1 second, I need to go in the app. So the data is already connected. Yes. Let's do the calculation. Let's take a look. So now when I take a look at my historical demand, as you can see, the demand is jumping quite a lot. So especially here in this area, it was jumping up. This was once a Black Friday, and also here was a Black Friday. The advantage, because I modeled now this Black Friday, is that we have here in the future a high jump, because I told the system, careful, here will come up the Black Friday. So he estimated here a higher demand, but he actually did not destroy my forecast. Or also here, because this forecast, if I would not have used actually the model the Black Friday in there, he would directly assume a much higher demand for my future trend. But actually this demand was only so high at the end because of this Black Friday. So that's why it's really important that you actually model these additional future input factors. And here you can see it, and there was actually, here he directly can recognize this, that there will come the Black Friday, and then he has actually here also this outlier actually modeled. When we take a look here in this data, we also have here a positive trend. And here you see the future impact factors is only relevant here in this area. And what is also important to know, you can have actually multiple of these input factors. I modeled here one, but in the sample data itself, let me go back there. You can see that you can also model actually multiple of them. So what is, for example, a useful future input factors? You can, for example, model weekends in there. If you don't have any shipments on a weekend, or maybe you have a higher sales on a weekend, you can tell the system on this days is always a weekend. Then you can model certain promotions. For example, if you spend a certain promotion on a certain article, you can also model this promotion budget as a future input factor as an idea. And then, yeah, the engine has now the possibility to actually reconsider these topics in your calculation. Yes, so that's actually pretty much it. What I wanted to show you about for now about the demand forecasting app. Let's quickly take a look in the Q&A section if there were already some questions that we directly can take up. Currently, I think everything is answered, so nothing that we need to share in this round. So whenever you have an additional question, feel free. You can just write them in the Q&A, and then we will answer them. Okay, so then let's take a look back to our agenda for today. So we covered the demand forecasting app. Now, what else did we develop? So I think a pretty cool feature is that we have now the population data of the whole world actually available. And in the first step, so it can happen that we will integrate them in other apps too. But for now, this population data we made for you available in the supply chain map areas and also in the Isochrone apps they are available. And let me quickly show you how this actually will look like or how you can use this. So let's go back to the add-in, and we go into the supply chain map. In the supply chain map, we have here, like the whole time, we have these areas available, and there we have actually areas around the whole world available. And now let's take a look when we go, for example, to Europe and Germany. And then let's start, for example, with the states in Germany and generate a template. So then you will see that we have here now one additional column. This is actually the population. So as you see, it has normally population it has here even 2 digits, but this is actually a rounding topic that we have here. And this population shows how many people live in this state. And this is actually covered for all the areas that we provide. I will show you later. We also have this, how many people live, for example, in one zip code. And this kind of information can be highly relevant if you do, for example, some network design studies. How many people can you reach in a certain amount of time? This you can also do with the Isochrone app. I just want to quickly visualize you the states of Germany quickly, because what we also did, before we used for the scaling or for adjusting the color, we used actually the size of a state. This means whenever we had a bigger state, the bigger state actually had a darker color. What we changed now, that we use actually this population data also in the quantity field, and this has actually then an impact of how this color is actually generated. So, and in Germany, as you can see it, the biggest states is not directly the state with where most of the people live. So here, when you click now this state is called North Rhine-Westphalia, and here actually most of the population of Germany lives, and then you have actually the possibility to also check this and see this here. There is one topic what I also wanted to show you when we go back. This is available for all the layers what we have here, because what we actually did, we did an analysis how many people live in this area. So even if I go now here, for example, on a zip code level of Germany, I still have actually this data available, and then I can see. Sorry, I did a mistake. I had to deselect first the states. Now I exported the states and the zip code. So let me just deselect the states. Now we only have the zips. So there are quite many zips. It's around 8,000. And here we can also see now the population in each zip code. And that's quite a lot of areas. I prepared here already in a workspace for this demo. I prepared already a map where we can see it. So Germany zip 5 areas. Let's quickly load them, and then I can show you that you can also see actually the population here. Oh, sorry, something went wrong. This is a demo. Let me check what I did here. I'm not sure if I saved the map correctly. Looks like I did a mistake while I was saving the map, but not a problem. Let's quickly just visualize a couple of them. Let's just visualize this map. I just selected maybe the first 10. And you see, now we have here the zips. When you click on the zip, you can also here see directly the population field. So this is one topic where we integrated them. So this means on all areas that we have available in the supply chain map, we can see actually the population data. So then in addition, where are they also integrated is actually in, we also have the possibility to use actually the Isochrone app. So we have it in the Isochrone app and in the Isochrone Plus app. I will just show it for the Isochrone app itself because Isochrone Plus is pretty similar. So for example, if I select now one Isochrone, let's say Berlin, and here it can make sense that we have the possibility to show multiple layers, but if I want to take a look how many people I can reach, for example, in 40 minutes, then I would recommend to just set the layer to one layer, because this is my question. So how many people I can reach in 40 minutes travel time out of the center of Berlin? It will be quite a lot, actually. So then when I do the calculation, it will take some time, because in the Isochrone app, we have to query this data over and over in the background, because every Isochrone can have a different area. And then, we always need to analyze then how many people live actually in this area. So now he did the Isochrone calculation, and now he's calculating population. Now he is done. When you export this, here you have directly, so we can reach in this area that we selected like this number, like 4 million, around 4 million. And now when you put it on the map, then you can actually see the area to it. So this is the area. It's not only Berlin itself, right? It's 40 minutes. It's also, this is not only the area of the city of Berlin. We are also covering other areas. So it makes sense that it's above 4 million. So here you can see then how much people, the population that you can reach in this range. And this possibility you have actually here in the, you have this here in this Isochrone app, and also if you want to use it, you can also take a look. The same topic works also for the Isochrone Plus app. But because of time reasons, I think we can jump to the next one. It's the same concept. We also display then in every area how many people are there actually available then. Okay, so then let's get back. Are there actually any questions in the meantime, or everything clear? All clear? Good.
No, so there are a few questions, especially regarding the forecasting. And so there was the point, so one-off events like natural disasters, how we can consider them, or could they be considered? So that's really a super difficult topic, right? So regarding this events, right? So what the algorithm for sure needs, the algorithm has to learn from it, right? So from the past. So this means all the impact factors that we also would like to use in the future should be there also in the historical time series, right? So the simple reason for that is that somehow, so the algorithm has to learn from something, and that's based on the historical data set. And so this demand spikes, unexpected demand spikes, this was the next point. That's also a good point for sure. Unexpected, for example, then now Black Friday is not really unexpected, right? So this is really an impact factor that we cannot describe in the past. And then for sure also consider in the future that the algorithm is more or less also aware of this. So this is fine. Nevertheless, what also happens regarding the spikes, the algorithm will always learn from the past, right? Also, when it sees, for example, this kind of more or less unexpected spikes in the past, then it will also project in the future. But also, to be honest, it is not possible, for example, a natural disaster, right? So nobody can really forecast it, so at least we not, right? So that we can consider it. Hopefully, so my answer helps, right? So, but whatever you would also like to regard in the future regarding the impact factors has to be there in the historical time series. Perhaps that's the answer. I'm not 100% sure, Jordan. I think you raised the question if this helps. But this would be so the explanation for it.
Okay, thank you, Jan. So then I will actually quickly continue with the next topic.
There's one additional question from Ganga. How often will you update the population data, and as of what date are data in the app right now? It's a very good point.
Good point, yeah. So at the moment, we don't have yet the plan when to update it, right? So because we just integrated. But I think we will have to take a look, maybe yearly, we will have to take a look and to update this data.
Also, to be honest, we integrated them worldwide. So some of this data comes from 2020, yes. Some of them 21, right? So it always depends a little bit on the country, to be honest. But for sure, as soon as our source gets updated, we will then also update the data again. But so perhaps this gives you a first idea regarding the actuality of the population data itself.
Yes. Okay. So then what we also did, we did actually an enhancement in the geocoding app. And one of the visual impacts that you can actually see from the outside is actually that you have now the possibility to use a search string. Before I show you actually a search string, I just want to give a quick comment that we also made some general enhancement in the geocoding, and we are currently also still working on some further improvements. So the geocoding is for us an always ongoing topic to improve the engine, to find for you easier the geocodes and also more reliable. So maybe a quick update what we did in the background that you can actually not see directly in the beginning. We noticed that often we have actually a topic when you have a typo in your address data that our engine cannot find it. So what we are doing now is whenever you, for example, provide a zip code, and the zip code is actually found in our database. We have there a certain database with many zip codes of the whole world. And then we have actually a bounding box. This helps actually our engine to search in a certain area, in this certain area to find the additional result. So if you have, for example, now, a zip code provided and you have a street provided, but the street has either a typo or the street is actually not correct, then the result will be, for example, the center of the bounding box. This is actually one enhancement. What we did also, we got it actually from multiple customer feedbacks that this would be helpful. So this will actually help to find more geocodes, but actually then the precision is then only on the level of the zip code. Just to mention this enhancement. And then besides this one, we had also often the request, is there a possibility that we actually use a search string? Because the whole time, let's go directly back to the app itself, then I can show you how it looked the whole time. 1 second, I need to jump out of the presentation mode. And let's go into the geocoding app. So here, the contract of the geocoding app was actually extended by one additional field with this search string field. So all the old columns still work totally in the same way. The whole time we actually enforce that you provide us the data in a certain structure. So what is still required directly to mention, you always need to provide the country. Also, when you provide a search string, you still need to provide a country. Always best is if you provide a country in an ISO 2 format. This is always helpful for us. And then the whole time you had to provide either the state, zip, city or street. So they were optional, but as more as you provided, as easier for us it was to find it. So now we often heard from customers, sometimes it's quite a lot of effort to divide the address, what is often provided in one string, into these multiple fields. And that's why actually we integrated this search string topic. And give me just 1 second. Here I have already something prepared. Sorry, I think where it was, I don't remember. Then doesn't matter. I can also do it quickly live. I have too many sheets open. So whenever we want to use the search string, let's just focus on one. Let's just focus on one row and remove also quickly the formatting here. Let's say, let's also use Germany. And when you have a search string, the only way that the search string can work, you provide a country and a search string. You need to leave the other fields empty. Whenever you would provide one additional field, he would ignore the search string. So this is important to understand. Only provide a country and a search string. Also, one topic was, for example, in our engine itself, you can also search not only for streets, you can also search for certain, for example, the Brandenburger Tor. You can search also for famous places, for example. It would also work. And then you can do this, for example, in a search string, because there is not really a field here in our address where you can provide this, just as one example. And then you can provide this now like this, but you can also provide a certain concatenated address in here. And then we can also calculate now based on the search string. And we also find then the result, and then we can export it like it was, and he finds it then in Berlin, right? and provides you, as used, also the zip code and so on back. So with this search string, you can search also for famous landmarks, and you have also the possibility to fill in their actually concatenated address, and you don't have to split them. But our test also showed, just to be clear, whenever you have the data in a separated way, please provide them still in the separated way, because then we have many more possibilities to make multiple checks. For example, what I just told you, when we have a correct zip code and we know this is the zip code, we can return you the center of the bounding box. When you do this with a search string, we can search in our engine, but if the engine doesn't find anything, then we cannot just extract the correct street in there and so on if he doesn't have a hit. So this is definitely easier to use, but if you have already the existing structure available, we still recommend that you use actually the existing structure. So this was, for example, now this partially this update in the geocoding engine, and currently we are working already on additional improvements. So there are also in the next release, there will come also actually some additional updates regarding the geocoding. Okay, then let's jump back to the agenda. Besides the geocoding with the search string, we also have now, last time we introduced actually the inventory optimization. Yes, and there we have now also the possibility to do a scenario comparison. I just quickly can show you this one. Whenever we go to the inventory optimization. Second, I think there it is, inventory optimization. Let's just save this in the workspace that we created for this lockup 4.5. Then we can do the calculation. Yes, so maybe one word to this one in the scenario comparison, because we heard many customers want to run here thousands of SKUs. This kind of comparison has actually the possibility to compare a lot of SKUs at once. So that's why the comparison itself will be only on a high level data. Yes, so it will only mainly compare the topics. Give me 1 second. This is running in the background. It will take some time, but what I can do, I can quickly just go back and take a look here. Did we not use this also in the last time? Here we have already the inventory optimization was running here and saved here on the platform, while the other one is still running. So like you are used to, you have here now this create scenario comparison. And when I add this, then you see he directly detects, this is from the last demo, we detect 3 runs. And then we just say, inventory optimization, and let's create this one. And now we can see here in this table actually all articles that are actually available in this combination. So I had, I think, 3 runs, but 1 run was actually running 3 articles, and the other 2 runs always 1. So you have here then one new table. You can also have the possibility to actually search in this table, filter it, and so on. And as I mentioned, because the requirement is that when you, for example, compare thousands of articles, and then you want to have, for example, the highest saving potential, then you can just easily sort after the saving potential. And if you want to take then a look into into the detailed dashboard of the run, we have here the possibility that you can directly jump also from here to the original dashboard. So the scenario comparison, we decided this time that we only make a high-level overview, that you can directly compare thousands of SKUs, and then you can jump actually from the comparison dashboard here with these links into the detailed analysis of the original comparison. And let's take a look. I think we have also here one folder prepared. So Jan just shared it with me, what was the
inventory optimization.
Inventory optimization. There's actually a new feature I can also show you. I don't even have it on the list. Was also feedback from the customers. If you want to search now in the workspace or in your project, you also have this possibility. So here in this folder, in this inventory optimization, we have, for example, how many?
More than 900.
Yeah, here we have around 900. And here you also have now the possibility to create actually a scenario comparison for this one. We can also, yeah. Can also run this one. So this will still take a bit of time because we still need to fetch now the data from all the SKUs, but we did it on purpose only on the table with the main KPIs. To read all of them and put it in one dashboard would be not possible. But this is actually also possible and will be generated in the background, as you can see. There it is. So now we have it here, and then the table makes also more sense, right? Because it's a much bigger comparison, so you can still easily sort through them. You can filter, for example, for them, what is the optimized policies that you want to take a look. And then here you can configure the table if you want to see it more. You can also select here the table size and so on. This can be actually all configured. Yes, so and the main idea is actually if you have such a run of thousands of SKUs that we give you an overview where you have the highest saving potential, and then it makes sense to take a look at these SKUs first. And then directly just jump to the dashboard with this direct link here. Yes, so that's it regarding the inventory optimization, so that we introduced already in the last release, and now we also have this feature available for the comparison. Then let's quickly go back. Yeah, then there's one more thing I wanted to mention is actually this datasets for the lookup map layers. This actually came up based on the webinar in our last webinar that we had. Directly when I showed this topic regarding the map layers, I can quickly show again. We have introduced in the last webinar that we are providing map layers with data that is hopefully relevant for the logistics. For example, you have the possibility to take a look at this map layer, for example, this DHL locations worldwide. Then you see these are all the locations from DHL. And the topic is you can actually easily integrate these locations into a map. I will quickly show this again, that this is clear for everyone what I mean with this. If you go, for example, here, and visualize some locations. So this would be, for example, our customer data. And we have them in the US. Then you have here on the left side this map layers possibility. You can click here. And by default, the lookup map layer selected. You also have the possibility to create your own map layers. And now you can actually add, for example, these relevant locations, because here we have our customers in the US. So I think it would make sense to use the locations from Kühne+Nagel because they are really worldwide present. So they have relevant locations also here in the US. And now with one click, I actually added this data into the map. And what actually happened in the last topic, so many people were happy that we have this feature, but then there came the question, hey, can I actually use this data also for my own calculations? And how can I use actually this data? And this is actually what we just enhanced in this release. Whenever you go here to the map layers of lookup, there you can actually see that we deployed here now also a data set. If you click on this data set, then all the locations that we are actually providing are available in this data set. And you can go there and you can download them. So in the data set itself, there are multiple ways to download actually data. You can go, for example, here on the three dots, you can export it as an Excel, a CSV. Or you can also use it as a table link in our integrations. This is one way. If you already are in the add-in itself, you can also go to the Manage Dataset app. Here it is, Manage Dataset app, and then we want to download something. Then you can select the lookup map layers. You can select the data, and there you see then directly all the tables. So even with one click, you can export actually directly with one click all the data that we are using here, and now you have it here directly in Excel. This is the same data that we are using in the visualization. And then you can continue to work with them. If you want to, for example, use them in a network design study and so on, these locations, then you can directly download them and reuse them here later. So this was rather small update, but I think still really helpful that you also have this data available. Okay, so I think these are actually the topics that I wanted to cover from my side. Then maybe I take a quick look at Jan. So do we have any unanswered questions that are still open? Nothing so far. Everything looks clear. Then thank you very much for your time. So just one comment. Also this time we will actually provide the recording again whenever the demo is ended. And one more remark, if you, for example, use in the future, for example, the inventory optimization.
There's one topic, right? So what's about effects by promotions of competitors which may reduce own sales?
So it means negative effect on the own forecast, right?
Yeah.
So I think this is a question regarding the forecasting app. This is actually a good point. This means if a competitor makes a promotion, and this would actually reduce their own sales.
Yeah, I think so. To be honest, so for sure this has then also to be checked in detail on the concrete case. But the first idea is that we could also use an impact factor, right? Not a binary one, one with a real number in. That can then also describe this, but also here, right? It's important that this also happened somehow in the past, yes. That the algorithm can learn how your own sales was affected, or your own sales figures have been affected, right? So by this promotion of a competitor, and you could use there this kind of numerical impact factor to describe this, and then flag the points in time where this also happened, ideally with a kind of value.
Yes, but I'm pretty sure there is a possibility you can recognize it already. It would be just, for example, the Black Friday in the other direction. Mm-hmm. So, for example, if I go back to my Black Friday example, here, sorry, this is not a Black Friday example. Here, this one. The only way how he detected this, I just told him Black Friday, and our demand in the past was increased here. Mm. So this is how he detected it, right? So if we go, for example, now here okay, you cannot go in a negative demand, but you could reduce your demand to a low number or even to a 0, then it would also have this effect just in the other direction. So you can also model this. It's also possible to model it, yeah. But it's only really possible if you had already this kind of effect in the past. Yeah. This is what you need to tell the engine in your historical demand. Okay, I hope this answered this question. Okay, good. So there, Jan, while you came up with the question, there was just one point what I wanted to mention. You will be provided with the recording, and even if you need the recording later, whenever you go here in the Help Center and you go to our release notes, then you can actually see we will provide here this link always to this release video.
Yeah, so there is one last question. Could you please repeat the additional this additional column, right? So also in the demand forecasting app with this additional advertising spend. So this is, I think, the example of this numerical impact factor, you know.
Exactly. Yeah, I can go back 1 second. So I just saw that we have there, I think, a problem with the translation, because normally this word should be nicer. This should be another, so the promotion day. So one topic what I forgot to mention. We have actually these input factors. We have actually numerical and binary ones. So here in this example, you see both. So the promotion day, this is a binary one, and the shortened opening hours is a binary one. So this could be, for example, also weekend. Shortened opening hours, yeah. So also possible on a weekend. It's a yes or no decision, yes. And here in the additional advertising spend, this could be, for example, if you are making a promotion campaign and you are paying, for example, Google for some additional placements of your product, and then you could enter here, for example, the budget that you spent in the past to do this promotion. And this is then not only a yes or no question. If you did there something, you can actually influence it. So for example, you say here you spend 30, I don't know, 1,000 would be maybe a lot, but 300, for example, in this Google AdWords spending. And then later on, you can also spend different numbers. And then the algorithms try to detect, for example, if you have a higher spend there, how much is actually the input there. And this you can actually do with this additional advertising spend. And sorry for the wrong names here on top. It's not wrong, but they are not correctly translated. This will be fixed.
Alex, could you please show? Okay, now I think it's clear how to get to this site, to this demand forecasting app, right? So for someone who joined later.
Okay, yeah, to the demand forecasting app, it's a new application. You just go here when you're on your home screen on the plus, and then you can go here to it's under predictive analytics, and here we have then the demand forecasting. So, and in this case, when you don't have the app activated yet, it will look like this. Then you just click here on this yellow star, and then you have then it will be added here. And then, as you are used to, you can also place it somewhere else. Yeah. Okay. Good. I think then if there are no other questions, then we cover this one. So I try it one more time. Whenever you want to see always the release notes from the past, you can also go just to our release notes itself. And yeah, during this end of the week or beginning of next week, there is also then a link to the recording. So this is mainly relevant if you, for example, want to take now a look at the inventory optimization, then you can read here the release notes, and here was then also the webinar is also here provided for the release notes. Even if I think when it tells you after a couple of days, the regular recording will be deleted, but here we also uploaded it on YouTube. Okay. So I think then we covered everything. Then thank you very much for your time, and then we can close the meeting. And I think you can still ask some questions in the chat, so we can still answer them. And thank you very much, and have a great week. Bye.